Let's look at section 4.2, the substitution method. In the substitution method, the idea is to take one variable and plug it into the other. Notice in example 1, the y is already solved. It is equal to x minus 3. And the idea is I'm going to take this and plug it into the second equation. This is going to give us 7x minus 4 times, we're going to substitute the y with an x minus 3. Don't forget to put parentheses around it when you do substitution. And now we can distribute. We have 7x minus 4 times x is 4x. Negative 4 times negative 3 is a positive 12. And this is equal to 27. Let's start by collecting like terms. 7x minus 4x is 3x. And we have plus 12 equals 27. The next step is to subtract 12 to both sides. This gives us 3x is equal to 15. We can divide both sides by 3 now. And our first solution is x equals 5. We're not done yet. We have to solve for y as well. And to do this, we're going to use substitution again. We can plug in x equals 5 into the first equation, or we can plug it into the second equation. It's really up to us. But I noticed that the first equation is really easy to use, so let's use the first equation. And so y equals 5 minus 3 when we do the substitution, and y equals 2 is our second solution. We can write our final answer as an ordered pair. Let's write it as 5, 2. This is our solution for example 1. In example 2, again, the idea is to solve for one of the variables. Notice that x is already solved for. We'll take the 3/4 y plus 5 and we'll plug it into the second equation for the x. This will give us 8 times 3/4 y plus 5. That's what we're substituting in, replacing that x. Don't forget the parentheses. And that's equal to negative 5y equals 28. The next step is to distribute. We'll multiply 8 times 3/4 y, and then 8 times 5. 8 times 3/4 y, that simplifies. And so we have, that's equivalent to 6y. And then 8 times 5, that's 40. Minus 5y equals 28. I can collect like terms. 6y minus 5y, that's y. Y plus 40 is equal to 28. We can start subtracting 40 to both sides now. And y is equal to negative 12. Y is equal to negative 12. That's our first solution. And to solve for x, I'm going to plug it back into any equation I want. It looks like the first equation is the easiest one to use. So we'll plug it into that. X equals 3/4 times negative 12 plus 5. The 4 reduces to a 1, and that 12 reduces to a negative 3. 3 times negative 3 gives me negative 9 plus 5. And that means our second solution is negative 4. But we have to write our answer as an ordered pair. The solution is negative 4, negative 12. In example 3, again, I want to solve for one of the variables. We could solve for any one that we like, but if I look at the first equation, it looks like it's easier to solve for x. That's what we're going to do. So I'm going to transfer the first equation here to the right, and then solve for x. To solve for x, we'll subtract 2y to both sides. Let's subtract 2y to both sides. That gives me x equals 7 minus 2y. Now the x is solved for, and we can plug this into the second equation for the x. This gives us 4 times 7 minus 2y. When we do the substitution, minus 3y equals negative 16. This is the time to distribute. 4 times 7 is 28. 4 times negative 2y is negative 8y. We bring down the negative 3y, and that's equal to negative 16. Let's collect like terms. These two y's can be added together. 28 minus 11y is equal to negative 16. Let's subtract 28 to both sides to isolate the y. Negative 11y is now equal to negative 44. We can divide both sides by negative 11. This gives me y equals a positive 4. That's our first solution. Now we have to solve for x. We can plug this y into the first equation if we want to, into the second equation if we want to, or I can plug it into this equation, this new equation that we created from equation 1. So it doesn't matter which equation that you use, just pick the easiest one for you. So I'll use this third equation here, and that gives me x equals 7 minus 2 times 4, and if we simplify that, that's 7 minus 8, so x is equal to a negative 1, and we could write our answer as an ordered pair now. It's negative 1, comma 4. That's our solution. In question 4, again, you can try these on your own at any time. Pause the video. I will convert equation 1 and solve for y. So let's just jot it down here on the right, and we will solve for y. The reason I want to solve for y, it's because it's easy to do so. So I'll add 2x to both sides, and y equals 2x plus 3. Then we can substitute this into the second equation for the y. This gives me 8x minus 4 times, put that 2x plus 3 inside parentheses, and that's equal to 10. We'll start distributing now. Remember, when you distribute, you need to include the negative, so it's negative 4 times 2x, which is negative 8x. Negative 4 times 3, that's negative 12, and that's equal to 10. Look what happens. The 8 and the negative 8x cancels out, leaving us negative 12 equals 10. This is not true. This is a contradiction. So what does this tell me? This is a contradiction. So it's a false statement, which means we have no solution for this question. When you have a contradiction, there's no solution. In question 5, let's solve for one of the variables. It looks like it's easiest to solve for x. So let's use the first equation here to solve for x. I'll add 6y to both sides. X equals 6y plus 4. And then we could substitute that into the x of the second equation. 3 times 6y plus 4 minus 18y is equal to 12. Let's start to distribute. 3 times 6y is 18y. 3 times 4 is 12. And we'll drop down the 18y, and that's equal to 12. Notice what happens here. The negative 18 and the negative 18 cancels out, leaving us 12 equals 12. This is not a contradiction. This is an identity, which means that no matter what we use for x and y, we always have a true statement. What's our solution? This thing has infinite solutions, so we're going to put that it has infinite solutions. But what do those solutions look like? And that's where you have to write your ordered pair. Well, the first one's going to be a number, so we'll just call it x. Any x, and we'll leave it like this. just an x. For the second ordered pair, well, that depends on what your first ordered pair is. If the first number is an x, what's y? Well, we'll have to solve for y. So let's look at the first equation and we'll solve for y. And so let's write down x minus 6y equals 4 and we'll solve for y. I need to subtract the x to both sides. Negative 6y equals 4 minus x. I can divide both sides by negative 6 now. And so y is equal to 4 minus x over negative 6. And this is our solution. The ordered pair is of the form x comma 4 minus x over negative 6. Now that looks like a weird answer, but essentially this is our x variable, and this whole thing we solve for y is our second variable. So whatever we pick for x, we can plug it into this formula and we know what the y ordered pair is. Essentially these two lines, line number 1 and line number 2, are lines that lie on top of each other. So that's why we have infinite solutions. These two lines lie on top of one another. In example 6, again we'll use the substitution method. This one's a little bit more difficult to use. I can solve for x or y in any equation that I want. For me, it looks like the easiest equation to solve for is the second one, and the easiest letter to solve for is x. Let's do that. 2x plus 4y equals negative 14. I will divide everything by 2 just to simplify the equation. X plus 2y is equal to negative 7. I can now subtract 2y to both sides, and that gives me x is equal to negative 2y minus 7. This is good. We have x equal to something, and we can plug that into the other equation. And we'll use this to substitute into the x. Now, if I solve for one of the variables in equation 2, I should plug it into the other equation. You must use the other equation in order for the substitution method to work. So we have 5 times negative 2y minus 7 minus 3y is equal to 14. I can distribute the 5. This is negative 10y minus 35 minus 3y is equal to 14. We can collect like terms. Negative 10y and negative 3y together is negative 13y minus 35 is equal to 14. Let's add 35 to both sides. And so we have negative 13y is equal to 49. I can divide both sides by negative 13. And that gives me y equals negative 4. That's the first part of our solution. And to solve for x, I can plug it into this equation here. This equation that we created when we solved for x. So we have x equals negative 2 times negative 4 minus 7. And so this simplifies to a positive 8 minus a 7, or x being equal to a 1. And we can write our answer as an ordered pair now, 1 comma negative 4. This is our solution. In example 7, again, we'll have to look for the easiest variable to solve for. I think in the first equation, the easiest variable to solve for is the y. And the reason I think that is it gives me the least amount of fractions. And that's from experience. You can figure out on your own what's the easiest one to solve for. And I'm guessing it's the first one from my experience. So let's solve for y. We'll subtract 3x to both sides. This gives me 2y equals negative 3x minus 2. And I could divide everything by 2 now. This gives me y equals negative 3 over 2x minus a 1. Still has fractions, but you know, that's the best we can do in this example. And now I can plug this into the second equation for the y. Negative 2x plus 7 times negative 3 over 2x minus 1 is equal to 43. Let's distribute that 7. This is looking ugly, but it's okay. We can still do this. Negative 2x minus, we have 7 times negative 3 over 2. That's negative 21 over 2x. And 7 times negative 1, that's negative 7, equals 43. To add negative 2x and negative 21 over 2x together, I need a common denominator. Let's multiply the top and bottom here by 2. So the numerator becomes a negative 4, and the denominator is just a 2. So now we can add this fraction together. This becomes a negative 4 over 2x minus 21 over 2x, which actually becomes negative 25 over 2x minus 7 equals 43. Let's add the 7 to both sides. And so we have negative 25 over 2x equals 50. I can multiply both sides of the equation now by the reciprocal. That's negative 2 over 25. 2 over 25 to both sides. And look what happens. We finally get x by itself. X equals, this simplifies to a 4. That's great. X is equal to 4. And now we could solve for y. I can plug this right into this equation. This one's the easiest. It's already solved for in terms of y. So y equals negative 3 over 2 times 4 minus 1. And this reduces, and that reduces. So you get negative 6 minus 1. Leaving us with y equals negative 7. Our answer, 4, negative 7. That's our ordered pair.